sometimes we're going to have to use the chain rule combined with another rule, like the product rule or the quotient rule or the chain rule again. And the simplification for these problems can get really complicated. So I'm going to show you some tricks that really help to give kind of a uniform answer so that you can check your answers, so that you can know if this is the same answer or if it's a different answer. The first thing to notice is that we have a product. X squared is being multiplied by the square root there. And I'm going to change the square root to a power. So this is 1 minus x squared, but it's to the power of 1/2. So the power rule is f dg plus gdf. F dg plus gdf. So that's what I've chosen for f and g. F prime of x is equal to f dg plus gdf. F times the derivative of the g function, which will, in our next step, require the chain rule, plus g df x squared. F prime x squared times, okay, the derivative of this piece right here requires the chain rule. The chain rule is the derivative of the outside times the inside times the derivative of the inside. So the derivative of the outside is 1/2 times a quantity to the negative 1/2. I'll subtract the 1. Then you drop down what was already in the parentheses, 1 minus x squared. The derivative of the outside times the inside times the derivative of the inside. What is the derivative of 1 minus x squared? Well, pop down, power down. So negative 2x to the 1. And the derivative of 1 is just 0, so that does not affect it. Negative 2x is our derivative of the inside. That's being added to 1 minus x squared to the 1/2 times the derivative of x squared is, pop down, power down, 2x. You have a term here, it's all a product, plus a term here, it's all a product. So let's simplify these two terms and see what happens. F prime of x. Okay, so what we end up having is x squared times 1/2 times negative 2 times x. Okay, so that would be negative x cubed, right? Negative 2 over 2 is 1, x times x squared, and then don't forget your negative. And this is being multiplied still by this quantity to the negative 1/2. Added to, we'll put the 2x in front, 1 minus x squared to the 1/2. Now my two terms actually have something that kind of looks like it's in common. Even though the quantities are not to the same power, I'm going to factor this quantity out. And the quantity that I'm going to factor is the most negative one. Okay, so when I take 1 minus x squared out, I'm going to take it out and put it to the power of the most negative power that we have here. Okay, when you factor, you are dividing this from each of the terms up above. Okay, so if you take this term and you divide this quantity, what do you get? You just get negative x cubed, right? That's all that's left. Plus, now if you take this term and you divide 1 minus x squared to the negative 1/2. Oh, wait, if you were dividing by a quantity to a negative exponent, that's really just multiplying by that quantity up above, which ends up giving you 1 minus x squared to the positive 1/2. And when you multiply the same base times the same base, you add the exponents, which 1/2 plus 1/2 is 1. So after all that, when you divide this term by 1 minus x squared to the negative 1/2, you end up getting, the 2x is still being multiplied by it, you end up getting 1 minus x squared to the positive 1, because 1/2 minus a negative 1/2 gives me that quantity to the positive 1. And we're almost done. We still might have some like terms inside of here that we can and should simplify. 1 minus x squared to the negative 1/2. Yeah, this will end up going into the denominator too before our final answer. So negative x cubed plus distribute this. And that's why we factor out the most negative one, so that this quantity will end up being to the power of 1. If it doesn't end up being to the power of 1, then you did something wrong, okay? Then you didn't factor out the correct quantity. So that's 2x times 1, and then 2x times negative x squared is negative 2x cubed. 1 minus x squared to the negative 1/2. Again, this will go in the denominator. Negative 3x cubed, right? Negative 1 minus 2 plus 2x. I am going to finish off with writing it as a fraction and factoring anything possible that I can. So this goes into the denominator, 1 minus x squared, and now it's going to be to the positive 1/2, which is the same as the square root of that quantity. And then in the numerator we have this quantity, but I can factor out an x, and usually the answer key gives the answer factored, so I am going to factor it. And so I'm going to take out an x or a negative x, whichever you prefer. I'll take out a negative x, and this would be 3x cubed minus 2. Or you take out an x and you get negative 3x cubed plus 2. Either way, you still get the derivative. And if you didn't factor the numerator, it's always a good idea to attempt factoring at least, so that you can make sure you have reduced everything. But this answer right here would also not be counted wrong. Okay, that would be an acceptable answer. Any of these. With this one, there are several things that I can do with it. Okay, this is gonna require the chain rule and the quotient rule. This can be brought to the power of 1/3 instead of a radical. Me personally, I do prefer the product rule to the quotient rule, and that's what I'm gonna do for this. I'm gonna take this quantity and bring it up to the negative 1/3. So f of x could be rewritten as x times x squared plus 4 to the negative 1/3, meaning it was supposed to be in the denominator. And now we will use the product rule and the chain rule to solve. So that will be f, and this whole thing will be g, f dg plus g df. The derivative in here will require the chain rule, so x times pop down, power down. The chain rule states the derivative of the outside times the inside. I'm going to subtract 1 from negative 1/3. So negative 1/3 minus 3/3 is negative 4/3. Same thing on the inside, and then times the derivative of the inside, which is 2x plus 0, or just 2x, plus this quantity times the derivative of x is 1. Okay, again, we have two terms, this product plus this product. Go ahead and simplify each of the two terms. So we have 2x times x times negative 1/3. That would be negative 2/3 times x squared times the quantity x squared plus 4 to the negative 4/3. And that will be adding just x squared plus 4 to the negative 1/3. Now we'll do what we did in the last problem. We will factor out the most negative commonality. So this quantity is in common, okay? But we're going to take out the one with the power that's most negative. X squared plus 4 to the negative 4/3 times this quantity divided by this is this, plus, okay, this quantity divided by x squared plus 4 to the negative 4/3 is really just this quantity being multiplied by x squared plus 4 to the positive 4/3. And when you're multiplying the same base, you add the exponents. Negative 1/3 plus 4/3 is 3/3. So you have x squared plus 4 to the power of 1. Okay, I do need to combine and simplify everything inside of this bracket, but this is a fraction and these are not. So I need them to all have the same denominator so that I can combine them. So these each need to have the denominator of 3, so I'll multiply by 3/3. 3/3 times x squared is just 3x squared over 3. 3/3 times 4 is 12/3. Combine inside of the brackets. You have negative 2x squared over 3 plus 3x squared over 3 is just a 1x squared over 3 plus 12/3. If we write that as one fraction, then we can separate its denominator. This is x squared plus 12/3. So this is a piece being multiplied by this piece, but this, because of the negative exponent, needs to go to the denominator. So we're going to write it right next to the 3, and x squared plus 12 will stay in the numerator. X squared plus 12, and that was over 3, but that was all being multiplied by this to the positive 4/3. Okay, most answers that I saw, unless it's a square root or cube root or fourth root, if there's something in the numerator besides 1, they leave it in fractional exponent form, but if it's to the 1/2, they put it back into radical form. Okay, this is just mostly for when you're looking up answers, just so that you know kind of what to look for. There we go. Now we have an entire quotient being squared. And in this one, I am going to use the quotient rule. And in the last one, you could have used the quotient rule. If you like it, go for it. Sometimes it is easier to use the quotient rule than the power rule. So let's use the quotient rule here. Because the entire function is being squared, we'll begin with the chain rule, and then in order to derive the inside, we will need to use the quotient rule. So f prime of x is equal to the derivative of the outside times the inside times the derivative of the inside, this entire quotient. Because most answers are left factored, we'll leave the 2 in front and we won't distribute it. the derivative of this quotient. This is the lower function. This is the upper function. Low D high minus high D low. Over low squared we go. Okay, we still have some more things to derive, but we're getting there. The derivative of 3x minus 1 is just 3. And then we're subtracting 3x minus 1 times the derivative of x squared plus 3. That is pop down, power down, 2x to the 1 over, of course, low squared. We go. Time to distribute so that we can combine like terms. I want to distribute this negative 1 at the same time that I distribute this 2x. So what I like to do is change this to a plus and then put the minus on the 2. So it's a negative 2x being distributed in. 3x squared plus 9 minus 6x squared plus 2x over x squared plus 3 squared. Combine like terms in the numerator. That's a negative 3x squared plus 2x plus 9. Okay, you have basically a fraction times a fraction times a fraction. So really we can multiply straight across the numerators and straight across the denominators. But we don't actually want to distribute or unfactor. So when I say multiply, I mean just like literally write it next to each other. So our numerator involves this 2 times this quantity times this quantity. Now, I'm not a huge fan of the negative being in the front, but you don't have to factor out the negative. But I am going to because that's my personal preference. I will not count it wrong if you don't factor out the negative. I will count it wrong if you have part of your answer factored and then part of it is not. I will factor out the negative. I'll put it right here, which just changes the sign of all the things inside of this parentheses. That would be 3x squared minus 2x minus 9. And that is over the quantity x squared plus 3 to the power of, this one's to the power of 1, this one's to the power of 2, so there are 3 of them total. Check just to make sure everything is completely factored, and you have your answer. Okay, product rule and chain rule because of this little 2. So we have F and G. FDG plus GDF. FDG plus GDF. Continuing to derive, we have, this one's going to require chain rule because we have a quantity to a power. So the derivative of the outside times the inside times the derivative of the inside. Please don't forget the derivative of the inside. That's just 4 plus this quantity squared times the derivative of 2x plus 3, which is just 2. Same thing. We're just going to try to clean up the terms that we have here and factor anything. Let's multiply these. 8 times 2x plus 3 times 4x plus 5 plus, this is a 2 in front of this quantity being squared. Okay, this is what I'm talking about. This piece is factored, but because there's a plus sign in between, it's not fully factored. So this is an example of a partially factored mess. So let's clean it up. I'm going to factor out the quantity 4x plus 5. We always factor out the smallest amount, so I'll say this is 4x plus 5 to the 1. When you factor that out of these two terms, you're dividing this term by 4x plus 5, which leaves us with 8 times 2x plus 3. And then when you divide this term by 4x plus 5, you still have the 2 being multiplied by the quantity, but now the quantity is not to the power of 2, it's to the power of 1. Distribute and simplify inside of the brackets. 16x plus 24 plus 8x plus 10. (24x plus 34). This right here, still not fully factored, okay? Because 2 goes into 24 and 34. So factor out that 2, and then divide each of these terms by 2. 12x. Now, is it fully factored? Yes, it is.